We're going to talk about the transformations of functions, and the first transformations we're going to talk about are vertical and horizontal transformations. And I'm going to start with vertical transformations. And they are set up as follows. Say we have y is equal to f of x. So y is equal to some function of x. In order to shift this graph vertically, I'm going to add a constant to it. So this would shift this function up if it were on a graph. If I wanted to shift the graph down, or the function values down, I would subtract. And this will make a lot more sense when we do an example. So let's do one. Let's say I have y is equal to the absolute value of x minus 2. So here f of x is the absolute value of x, and c, the constant, is minus 2. So according to this graph, or the solution of functions, or the solutions for the function, would be the same as y is the absolute value of x, but minus 2. So let's make a table. It'll be a lot more clear. So let's say we have x and y, and let's find the values for y is equal to the absolute value of x. We'll do minus 2, minus 1, 0, 1, and 2. So for we're just going to take the absolute value of x. So for this it would be 2, for this it would be 1, absolute value of 0, 0, 1, and 2. Now let's find the values for y is equal to the absolute value of x minus 2. So first let's find, well, let's do all of these. Minus 1, minus 2, 1, 0, 1, and 2. So let's start with minus 2. The absolute value of minus 2 is 2 minus 2, which is 0. So essentially what we've done is the exact same thing as this function, but we've just subtracted 2 on top of that, and that's exactly what this function is doing. It's doing the exact same thing as this. We're finding the exact same x's, but just in addition, or in this case subtraction, we're taking 2 away. So here it would be the exact same as this one, but just minus 2. So this would be minus 1, and if we solve it, x is equal to y is equal to the absolute value of minus 1, which is 1, subtracted by 2, which is minus 1. So here we can just subtract 2. So this would be minus 2. And if we do that, y is equal to the absolute value of 0 minus 2, which is minus 2. So you see what is happening here. It is the exact same thing as this one, but we're just subtracting 2 from the total answer for our y value. So that's why it's only affecting the vertical position of the function. And this won't affect it horizontally at all. So if we decide to add 2 to this, then what would happen is our y value would increase by 2 instead of being subtracted by 2. So let's finish these off. So we have minus 2, this would be absolute value of 1, minus 2, which is minus 1, the absolute value of 2, minus 2, which is 0. So let's graph this. And we'll put both of them on so we can compare them. So let's begin with the first one. We had 0, 0, which is just our plane y is equal to the absolute value of x, 1, 1, 2, 2, minus 2, 2. So it looks like this. This is the So this is the function without the transformation. This is this right here. Now let's put our vertically shifted one, where it's shifted down to. So we predicted that's going to be shifted down to, according to the way the function is set up. So minus 2, 0. Minus 2, 0, that's here. Minus 1, 1, that's here. And we have we have 0, minus 2, 1, minus 1, 2, 0. If we connect these dots, we're going to see that it is exactly what we predicted. So this center right here is at 0, 0. This one is at minus 2, 0. So it is shifted down to. This is 2 units apart, this is 2 units apart, this is 2 units apart. No matter where we go down here, it's always going to be 2 units apart. And if this had been, let's say we wanted to know y is equal to the absolute value of x plus 2. Well, now that we know how the vertical shift works, we know that this would be 2 units up, so all we would have to do, we wouldn't have to make a table or anything. We'd just go up 2 units and say, well, it's the exact same thing, but just up 2 units. So that would be this. And that is how vertical shifts work. We have a function that we're familiar with. So we have a function we're familiar with. And then we know that these just change. So if we add or subtract a constant to a function that we already know, all we're doing is just changing the vertical placement of it. So now that we've talked about vertical shifts, let's talk about horizontal shifts. And horizontal shifts take place when we have y is equal to f of x minus some constant, or y is equal to f of x plus some constant. And when we're subtracting a constant, it is going to shift it to the right, and when we're adding a constant, it is going to shift it to the left. And let's try to understand what is happening here. Here, when we had a vertical shift, we were finding the value of some function x, which normally gives us our y. But then on top of that y, we are adding or subtracting some number. So we have an x, and then we get a y value, and then we add or subtract some c. So that will change the vertical location of it depending on how much we add. For a horizontal shift, this is influencing the x. So let's say if I have f of x minus 1. What I'm essentially solving for, and let's say I said I want to know what x is equal to 1. Essentially what I'm solving for is the previous point. So it's going to shift it over to the left. So this would be x minus 1. So I'm actually giving the function value for f is equal to 0. So let's make a table of this, and hopefully that will make more sense. So let's do the same. Let's make it a little bit different. Let's do y is equal to the absolute value of x again. So we have minus 2, 2, minus 1, 1, 0, 0, 1, 1, 2, 2. And this time we're going to do y is equal to the absolute value of x. We'll do plus 1. That's a little bit hard to see. Absolute value of x plus 1. So let's put in minus 2. We get minus 2 plus 1, which is the absolute value of minus 1, which is 1. And when we're adding, according to here, we're shifting over to the left. So we're solving for the next point, essentially. And this will make sense once we've graphed it. So minus 1, add 1, take the absolute value 0. 0, we add 1, take the absolute value 1. 1, add 1, take the absolute value 2. 2, add 1, take the absolute value 3. So let's graph this and then we'll talk about it some more. So let's put the original one on again. So this is y is equal to the absolute value of x. And now let's start plotting the points for y is equal to the absolute value of x plus 1. So we have minus 2, 1. Our next point is minus 1, 0. Can everyone see that? Yeah. Minus 1, 0, 1, or 0, 1, 1, 2, and 2, 3. So connect the dots and we can see that it is shifted over to the left one. And I'll explain why that is. So like what I was trying to explain earlier, which is a little bit difficult to see, but now it should be a little bit easier to see in the graph. See, these two functions are almost identical, except the x value is being added by 1. So when I'm solving for 2 here, or let's just use the points we're using. So when I'm solving for minus 2 here, I'm putting in 2 here, but what I'm actually doing is putting in minus 1 basically, because I'm adding 1. So I'm actually solving for minus 1 of this graph basically, because it's like this function is one step ahead of this function. Think about it like that maybe. This function is exactly the same, except we're solving for x's one step ahead of it. So when this function is being solved for minus 2, when we put in minus 2 for this function, we're actually solving for minus 1 of this function, essentially. Because when we put in minus 2 here, this becomes a minus 1. So the minus 2, x is equal to minus 2 here is the same as x is equal to minus 1 over here. And we can look. So when x is minus 2 here, we can look at our minus 1, and the y value, see, look, 1, 1. This function is one step ahead of this function. And if it was, or actually let's continue. So when this function is minus 1, it is 0. It's one step ahead. See, when this function is 0, it's 0. When this function is minus 1, it's 0. So it's one step ahead. So it's like this. where the y values are equal. So this 2 corresponds to this 1. This 1 corresponds to this 0. This 0 corresponds to this minus 1. This minus 1 corresponds to this minus 2. I hope everyone can see that, where this function is exactly the same as this function, except we're adding 1, so it's like we are solving this function except one step ahead, except one number ahead of it. So I mean, if you don't see that, just work through a few examples and hopefully you'll see what I'm talking about. But that's all this is doing. If it was the y is equal to the absolute value of x minus 1, then this function would be like it was a step behind the original one. So it would be over here, like this. And its y value, this function's y values would be a step behind of this one, of the original one. But in this case, since we're adding 1, this function's y values are one step ahead of the original y function. So this is all there is for vertical and horizontal shifts. When we have, let's just quickly review. When we have y is equal to f of x plus or minus some constant, then it's a vertical shift. It's a shift up. If it's plus, it's up. If it's minus, it's down. When we have y is equal to f of x plus or minus some constant, when it is plus, it is a shift to the left, because this function is one step ahead. When it is a minus, this function is shifted to the right because it is one step behind.